Hello students, welcome to section 2.1, quadratic functions. In this little warm-up today we're going to go ahead and solve each of the following. Number one, it says solve the absolute value of x squared minus 2x equals x, and we're going to solve for x. Now because this is an absolute value, we do need to split the problem into two different cases. So if you remember from Algebra 1, when a problem like this presented itself, you would take the absolute value and you'd rewrite it as in one case x squared minus 2x, and in the other still x squared minus 2x, where on the first it's positive, whatever the right side of the equation ends up being, in this case positive, and in the other case negative. So there's a positive, so to speak, version, and there's a negative version. The left side is the same for both. Then you just solve each one, as you know. So if we subtract x from both sides, we get x squared minus 3x equals 0. We can factor nicely, so x factors to then lead to x minus 3, still equals 0. One solution is 0, another is 3. The other quadratic, if we were to add x, we see this equation take shape, so now equals 0. Factor out the GCF again there of x. You do that, you're left with x minus 1, again still equals 0. This solves to be 0, this solves to be 1. Your three answers in this particular case are 3, 0, and 1. That fourth answer, because it's repeated, we're only going to count it once in our solution set. Problem number 2. The absolute value of x squared minus 2x again, except now 3x minus 6. So for case 1, we set it up accordingly. X squared minus 2x equals positive 3x minus 6. And the other x squared minus 2x equals negative, but make sure parentheses are used surrounding your 3x minus 6. I'll balance the equation, subtract 3x, add 6, there it is, set it equal to 0. This can factor as such, x minus 2 and x minus 3, set it equal to 0, and there you have it. The factored form lends itself, of course, in the final answer there as x equals 2 and x equals 3. As we continue, we can see here that this setup entails in the next step distributing the negative. So on the right side there, negative 3x plus 6. We add 3x, we subtract 6, of course it's now equal to 0. We can factor this such that what? X minus 2 times x plus 3 equals 0. This, if you set equal to 0 like before, we end up with x equals 2. And if you set it equal to 0, you get x equals negative 3. One thing that I do suggest, I didn't do it on the last problem, although I'm going to recommend it now that we're done with both, and that is checking your solutions. It turns out if you check your solution, yet again 2, because you see it's repeating itself, you only count it once in your final answer, but also 3 is an answer. It turns out negative 3 is not a solution, and if you were to graph this, or if you were to plug in negative 3 for that matter into x here, here, and there into the original equation, negative 3 technically is not a solution. Everything else does work. Graphically speaking, again, by the way, when it comes to that, you will see only those two solutions. We are going to talk about graphing. But to kind of save a little bit of time here, if you were to graph this as y sub 1 and this as y sub 2, so the left side versus right side comparison, you're only going to see an intersection of x equals 2 and x equals 3. Similarly on number 1, only those three solutions, like I said, are answers. Graphing the left side as y1 and the right side as y2. So certainly I recommend checking your answers anytime you have an absolute value in an original problem. Today our discussion will segue into definition of a polynomial function. Letting n be a non-negative integer, and you see a sub n minus 1, and so on all the way to a sub 0. So your subscripts are getting smaller. Just to kind of highlight the fact that your coefficients, which you'll see here in a moment, are also kind of descending, so to speak. Not necessarily in the sense that the numbers are descending, but in the sense that each respective coefficient of the respective variable that it's multiplied by, those are descending because of the nature of the exponent. X to the n minus 1, and so on and so forth, until you have a constant term there at the very end. So this is the chain of coefficients, and let them be real numbers with the leading coefficient is what we say not equal to 0. And the function takes shape as such. F of x equals a sub n times x to the n, and so on and so forth. A very easy way to think of it, if you just kind of keep in mind quadratics, for example, x to the second power, or 1, you can say x to the second plus, I don't know, another coefficient like 2, x to the first, all the way down to a constant like the number 2, that kind of thing. Again, it's a polynomial function of x with degree n. Speaking of degrees, the degrees of a polynomial function we have, again, based upon what the largest exponent is on the independent variable. I already described a quadratic, but this right here would be a 5th degree. Why? Well, the highest exponent, the largest on the very first term you see there is 5. Certain degrees are referred to by a specific name. So if it's a 0 degree, in other words x to the 0, or if it's just a number, because remember anything to the 0 technically is 1, we have a constant. If it's a 1st degree, it's linear. 2nd degree, quadratic, like I mentioned already. 3rd degree is cubic. 4th is quartic, and then 5th is quintic. We don't typically go beyond 5th degree naming, so keep those 6 in mind. For the most part, in most of the questions we do, you'll see that kind of general setup and naming. As we continue on, so classification, I'll walk you guys through. Classify each of the following polynomial functions by degree. This first one is a constant because it's just a number, and it's a monomial because it's only one term as opposed to more than one. This next one, number 2, 12x cubed minus 5, this is a cubic because the highest exponent there is 3. And it's a binomial by virtue of the fact that we've got 2 terms. Number 3, 3x minus 5, this is a linear because the exponent here is 1, it's x to the first if you think about it. And it's a binomial because, again, there's 2 terms. The last one here, negative 16t squared plus 24t plus 32, is a quadratic trinomial. Highest exponent is 2, and there's 3 terms. If we extend beyond 3 terms, we just call it a polynomial. So, in theory, you could have a cubic polynomial because there could be 4 terms with a degree of 3. The definition of a quadratic function. So let a, b, and c be real numbers with a not equal to 0. The function, as you probably remember from Algebra 1, f of x equals ax squared plus bx plus c. And yes, it's called a quadratic function. Writing quadratics in standard in our textbook, it actually will bounce back and forth between standard and vertex form as far as a name goes. Certainly, if you reflect upon this right here, this will help you find the vertex very quick and simply by looking at what we call the h and k values. There are problems in which maybe you don't start here. You start with this right here. This is the definition of, again, what you've typically seen as a standard form quadratic. But notice the language is actually using standard instead of vertex. So they'll go back and forth. Usually we call this standard and we call this vertex form. Again, our textbook is a little bit more nuanced in that regard. So pay attention. The quadratic function, like I said, that technically is quote-unquote standard form, although the vertex is going to be really quick and easy to highlight here. F of x equals a times the quantity x minus h squared plus k. Again, a can't be 0. I just said it was standard form. So let's see what happens. The h comma k, as I described earlier, is in fact your vertex. So if h is one number and k is another, you know the ordered pair of the vertex. It describes how if a is greater than 0, the parabola opens up, and if a is less than 0, the parabola opens down, as you hopefully remember. So the vertex actually also, if you think about how a, b, and c fit into the context of, again, this equation, it also needs to be noted that negative b over 2a is another form that we can utilize to find the h, or you can just say the x coordinate of the vertex. I could also say h, of course. Once you find h, or again the x coordinate of the vertex, you plug it in to find y. You could either plug it in to the vertex, aka standard form, or you could plug it in back if in fact you had the kind of what we again note as typically the standard form. So I'll be careful as I describe things. I do typically call this standard form, frankly, based on other textbooks, and I usually call this vertex form. Just something to keep in mind though, but this version is certainly useful as well. I didn't speak to the vertical line whose axis is kind of cutting, the parabola of which has an axis that cuts it in half. X equals h will give you that symmetry. Alright, so for number 1, it says find the equation of a parabola in standard form, okay, that has a vertex of 1, 2, so h, k I've already noted, and a equals 1. Does it contain the point either one or the other? So is it this point or that point? I've already crossed off this point because it turns out, and you'll see my math here in a moment, that it doesn't technically work while the other one does. But why is this? Well, let's just see. So again, here's our form. We already know again h and k. So h is this, 1, and k is that, 2. So for our purposes here, if you know a equals 1, you plug it in. So you're going to have two different versions to test. You're going to test the first version of which has a y of -6 and an x of 3. So is that ordered pair on the parabola is really what you're thinking. Well, if you do that math, you'll find that -6 does not, of course, equal on the right side there 6. So no, this ordered pair doesn't fit on the parabola. However, 3, 6, well, let's plug in 6 for y. Plugging in 3 for x. Leave everything else as is, or h and k like before. If you do that math, you do end up with, in fact, 6. So that does check out. It isn't, in fact, true that 3, 6 is on that parabola. Right here, the equation of the parabola proves that out. So for part B, find the equation of a parabola in standard form that has a vertex of 1, 2 if it does contain 3, -6. So in a sense, we're using what we maybe didn't get to work out for us on the last problem, testing the theory of what maybe A would be, and that's the hint here. So we're going to find A. Well, again, we know H and K, so here they are. Here's H, and here's K. Okay, you don't know A, so leave A as is. We're going to solve for it here in a moment. We're going to plug in 3 for x, we're going to plug in -6 for y, and we're going to do the math. Okay, this ends up being 4. This, of course, still stays as such. We subtract, we get -8. We divide, we get -2. And there you have it. That equation is officially going to have that particular point on it if you were to graph the parabola. So that's the equation of the parabola. That's the point, in fact, on the parabola, as well as the vertex for that matter. I do urge that you graph this on your own on your graphing calculator. For the sake of time, I'll ask that you do that on your own, but yes, you will find on your graphing calculator that all those points are on the parabola. So with the time we have, I will get through a completion of the square question, and I think it'll be a nice finishing touch here. Rewrite the following quadratic in standard form, and we're going to complete this square. So when it comes to completing the square, you may recall your process is entailed in the following way. You're going to rewrite with y, so take the original quadratic and turn it into an f of x. Now instead of that, turn it into y. Second step, you must have a equals 1. So in order to do that, you're going to factor out a -2. And in doing so, you're factoring out of the first two terms only. So you're left with x squared minus 6. This number came about not just in this blank spot initially, but also here by doing the 3 steps. Hopefully you recall, find b over 2, then find b over 2 squared. B is -6, divided by 2 is -3, squared is 9, and you write it here as well as there, but technically it needs to be a negative because it's on the same side of the equation. It's not on opposite sides. The -2 is multiplied here because you factored it out. I also pulled out the -14 from the beginning, and the rest is just factoring. So this quadratic factors as such. It's a perfect square trinomial. And then you go ahead and do the math out here. Put it all together, you have y equals -2 times the quantity x minus 3 squared plus 4. Please continue the rest of the notes on your own.